Okay, good afternoon everyone. I hope you can hear me okay. So my name is Jon Starck. I'm Head of Research at Foundry, and welcome to the R&D slot that we have every year here at SIGGRAPH. And this is the slot where we show you some of the experiments that we've been doing, looking at new types of tools that might be needed in the future for new types of visual effects or media production. So the theme this year is about new types of production techniques, and I'm going to tell you about two projects that we've been involved with. One looking at AR production and one looking at live action VR production, but for positional VR experiences. So two different projects, both with very exciting things to show you. So let's take a look. So the first project that I want to talk about is a collaboration between Foundry and ILM. This is a collaborative funded project in the UK, and it's funded by a government organisation called Innovate UK. And the goal, it's got a catchy title, Fame, is all about film quality, augmented and mixed reality experiences. And the concept that we're trying out here is to test out location-based AR experiences. So we're running a production test on location in different parts of London, where we want to create an AR experience for the viewer as they go to that location. And there's really two targets for us here. First of all, we want to make the experience an immersive experience for the viewer. So you're going to a particular location. We want to present the experience to the viewer through a tablet as a magic window. You can imagine that in the future these type of experiences might go to some sort of glass or AR headset. But we're starting off with tablet as a magic window. So you've gone somewhere, you're holding up a magic window device, and that's a lot of effort to go to. We don't want it to be a passive experience that you watch and plays back. We want the experience to involve the person that's viewing. So we want the content to interact with the viewer. We want content where there's dialogue to the viewer, or the viewer becomes involved in the story, or they can even reach out into that world and interact with the story as it unfolds. So that's one exciting concept we want to play with inside this project. And the other is to make it look really high quality, make it look real, give it that film or cinematic look. And that means embedding the digital content in the world around you in a realistic way. It's going to give you this cinematic quality to the experience. It's really going to make the digital content looks like it's with you, and that's what people are calling mixed reality these days, but it's all kind of AR. So that's what we're doing in this project. It's a collaboration, it's a partnership, and we're working with ILM, and there's several technical challenges to be able to deliver these types of experiences. And one is delivering the digital assets that go into the visualization. So ILM are looking at the pipelines to take film quality assets that are very high resolution, very complex materials, complex textures, large textures, and preparing them ready for real-time rendering and AR and VR experiences. So we're working with ILM, and they're providing digital assets to create this location-based AR experience. And we're working on the technical challenges to deliver visualization. And there's several parts to that. So first of all, you want to drop in a very beautiful looking digital asset into the environment around you. You need to be able to understand the geometry of the world. So the first part of the puzzle here is to be able to scan the world and build up a geometric representation. So this is our London HQ office. It's early in the morning, there's not many people around. They're rammed inside London Underground somewhere. And what you're seeing here, or what you saw just now, was a first pass at a prototype tool built on a Lenovo Fab 2 Pro phone that uses Google Tango to scan the world. So this device is doing active range scanning, and it's scanning the environment, building up a point cloud, and it's streaming it to a back-end server. The back-end server is building up the geometric representation of that world around us. So very simple, and these sort of devices, they work at a range of 0.5 meters up to 4 meters. So you can imagine standing here and start to scan the geometry around you. This is what process you go through. And these are the sort of results that you get out of that scanning process. And it's actually, I was quite surprised, the quality and accuracy that you can get. So to get to this geometry, it could take something like 5 or 10 minutes to scan parts of a room, 15 minutes to capture a whole room, and this sort of scale of geometry, there's different parts to our office in London on this floor, something like 20 minutes, half an hour. So there is a time to capture this, but it's not a long time. This is the sort of thing that might happen in an on-set environment as well, which is quite interesting. So this is illustrating the preparation stage to create an AR experience. So we've actually done this as part of the production already, gone out on location in London and started doing the scanning of the environment. The next step is to start building, don't know where to point this thing, building that into the experience. So we pull in the geometry of the world into, in this case, Unreal Editor, and we have our asset ingest, our delivered assets, and the animation data. And we can start to lay out the experience inside that environment. So this is a first test that we've done inside our office. The next stage that we're going to go through is preparing the animation data for the real locations inside London. So we're going to go to do a mocap shoot for this production to create set pieces of animation that correspond to the story. So when you go to the AR experience, the story unfolds around you and you can see and start to participate in some of the events for that story. So we do the development of the experience inside Unreal Editor. And there's two lessons that we've already had by going through this process. First of all, you capture the world once to prepare the experience. But let's say you turn up a month later and you want to see what that experience was like. Someone's come along and they put a chair in the way. So suddenly the world has changed and you either need to have procedural animation to be able to compensate the animation that you have, or you need to be able to recognize that the scene needs to be able to reset. So at the point of the experience, you need to recapture geometry. Again, that needs to be a simple, fast process, and you need to get deltas on the world that you've captured. The other lesson that we've had is that lighting is absolutely critical to getting high quality rendering where the rendering looks like it's integrated correctly with the world around you. And again, that lighting environment is going to change at the point of picking up a tablet and entering the experience. It might be in the morning, it might be raining outside, someone might have switched off the lights. So this again is something that you need to be able to capture when you're going into that AR experience. So what we're doing here is exploring AI, deep learning in fact, to see if we can automate the process of recognizing the lights around you just from a single photograph. So you pick up a tablet, you take a picture of the world, and you want to hallucinate an IBL, the environment lighting, and also importantly, the key light sources in the scene, because you need to inject those lights into the real-time engine to get the lighting and shadows, the real-time shadows that integrate the asset into the world as it moves around. So we're doing some experiments using AI to recognize lighting environments. And we've got to the stage where we've done the first render test. So be aware this is first rendering. We don't have the beautiful work from ILM to make this look as amazing as the original assets that were delivered. But here we have the asset sitting inside our London office. We have the recognized lighting environment from deep learning to lights in the engine. So this is Unreal doing the rendering. So this is the first pass at creating a test AR experience. And the next stages we're going to go through are to complete the production, do the mocap shoots, assemble the experience for different locations in London, and then deliver this to AR tablets. And the final piece of the puzzle that we're going to look at here is streaming. So streaming the render to the device. What we want is to achieve a very high quality rendered experience, but we want to deliver that to a lightweight viewer. So we need a back-end server rendering in Unreal, streaming the asset and the experience to the tablet device. So that's the next stage that we're going to go through. So that's some experimentation around AR production. The next project I want to tell you about is experiments and test productions on positional VR using light field capture. So this project, again, it's a collaboration. A lot of our tools development is done by working directly with clients, and in particular with projects like this, actually going into production and learning all the pain points and problems for ourselves. So we're partnered with Figment Productions in the UK. They produce some of their premier VR theme park rides in the UK and worldwide. and also with an academic institution, University of Surrey, who are experts in multi-camera capture studios. So live action performance capture, digitizing humans so that you can deliver them in real time, rendered inside a game engine. So this is the project that we're working on for VR. And again, we're going through the process of a real-world production to learn the problem. So this is a production called Kinch in the Double World. It's for a VR experience where you put a headset on, and there's some really interesting questions to ask inside this production. So it's a conventional stereo 360 production. I'll show you some images in a minute. We're using a Nokia Ozo to shoot the stereo 360. And we're going to mix that with live action foreground performance of characters captured with a light field rig. So light fields is a term that's been coined for multi-camera capture. So if you imagine 360 capture today uses a ring of cameras. You can actually see that one of the cameras over there, and there's a demo over there. So you capture with a ring of cameras looking outwards. And you can represent that as a 360 image, a sphere with video on it. If you enter into that VR experience, you're immersed in the world and you can look around. But that's the only thing you can do. You can only look around. And the illusion is broken because as soon as you move your head, or you actually pivot about the base of your neck, it doesn't move correctly. The world starts to swim. You're used to being in a real world that sticks as you move your head around. Now, how do you move your head? People call this positional VR. How do you move your head around inside that space? Well, the way people address it today is they do real-time rendering. So you capture an environment model. It's a CG model. You render it in real time to wherever your head is at that moment. And then the world is stuck, and you can move around inside it. With light field capture, what you can do is you can record the world from many different viewpoints. If you can replay those viewpoints from many cameras to wherever you are right now, you can replay the true parallax. You can generate that sense of change of perspective as you move your head around. So this is what people are trying to do with light field capture to create true positional VR experiences, because they'll give you a much greater sense of presence inside VR. So that's what we're doing with this test production. So I've got a little bit of, press the button again, I've got a little bit of B-roll. We've just come out of production, we've done the shoot, and we're going into the post-production process. So this is going to show you some of the shooting that we've been doing. Is that audio? Is there audio? There's some nice soothing music here. I can sing to you if you want. I don't think you'll like it. Not now. No, it's fine. So what we're showing you is it's an experience that follows a story of some orphans in Victorian England. It's using VR as a transportational tool. You put on a headset and you're transported to an alternate world, a historical world, where these characters are following a storyline. So we've shot some of it with stereo 360 using a Nokia Ozo, and some of it using this light field camera array. So this camera array records what the performance looks like from many different viewpoints, so we can replay that to create the sense of parallax. And I recommend sticking around for the talk after this one, because Nokia are coming along to talk about Ozo, the Ozo camera rig. Okay, let's move on. So that's a little bit of what we did in production, finished a couple of weeks ago. And this shows you that the rig that we've been experimenting with for light field capture. So there's 25 cameras on there, arranged in a 2D array. And that's going to capture a foreground character when they come close to camera. So we've done several production tests to see what it's like to put on a headset and view the world captured like this. And the lesson that we've had from these experiments is that it really has impact when characters come close to camera. So what you're trying to reproduce is the parallax that you see as you move your head around. And things in the mid-distance or background, you can't really see that parallax so much. You don't necessarily notice the occlusions or disocclusions as you look around something, but it does have an impact for foreground characters. And really, things like dialogue to camera, close to camera really works quite well when you're recording data like this. So we're doing performance capture for some of the characters in the story as they approach the camera and involve you in the story as you watch it play back. So that's why we're using volumetric capture or light field capture in this experience, but we're doing it to see what tools we need in applications like Nuke in the future to process and manipulate these types of data sets. So what you're looking at is a subset of these cameras. So I've picked out 6 cameras from that capture. With those 6 cameras, because you've got multiple points of view, you can reconstruct the depth of the world. So what you can see here is you can see through each image to the depth behind it. So you've got a depth per pixel, a Z value, RGB, A, and Z. So we can pull all those depth values together and combine them into a single video stream inside Nuke that represents the volumetric capture inside the world. So what I'm going to do here, let's see if I can remember. So I'm looking at the different depth layers that we've accumulated inside the scene, first of all. Showing the depth for the different elements. So the foreground character is darker, the Z value is smaller, they're closer to camera. And now we're jumping out to 3D. So you can see the original camera array, you can see the reconstructed depth, and you can see that there's perspective, there's parallax on the surface of these characters. If you're watching in a headset and moving your head around, you can see that they have depth, as if they're real, and you can see they're separated in depth. And once you can jump out into a 3D workspace like this, you can start to do 3D edit operations. So we can see top right, we've got the boom in shots. I want to be able to remove that from the scene, so I can do a selection. I can do that as a 3D process, and I can transfer the changes to the 2D video stream that we've got here. The other thing I can do is I can start to do crops and separate out the elements in the scene. I can do that in 2D, and I can also box them out and separate them in 3D. So there's a box around the foreground character. You can see actually the girl is in the background there as well. But somewhere in here there's a Z slider as well that I can select. So I can see the depth of her is further away, and then I can sort of slice that out in 3D as well. So this is going through an image-based process, pulling all the pixels together, using their depth values to integrate them into a volumetric video representation. So we're interested in what tool sets you need in the future to clean that up as an image-based process or a 3D process, how you can automatically transfer your keying across multiple views, prepare the color, ready to create the final integration in the CG scene. Oop. So the other thing we've been doing is looking at the different camera rigs that you can record this data with. So that rig that we just showed you was a 25 camera array, point grade cameras. This experimental capture is using a bunch of GoPros. So it really represents the kind of other end of the spectrum. And actually, if you're on the show floor here today, I do recommend going to the Immersive Experience Hall and taking a look at the Hallelujah experience. It's phenomenal. So that used the Lytro Emerge camera to do the capture, which really shows you what you can do at the professional end of light field capture. So this is perhaps at the other end of the spectrum, using 6 GoPro cameras in a line with an additional 7th camera in the middle. We use that to preview, to provide a preview monitor. So we took 6 GoPros, we recorded the scene, and then we pulled that into Nuke. And we reconstructed the depth using the Nuke depth tools. So this is showing the reconstruction from 6 GoPros, and you can start to see the sort of depth that you can get. There's a little bit of relief on top of the surface, but you can see that they're a 3D character now. So this is a bit of experimentation to see what we can achieve. And of course, the end delivery is that real-time playback inside a game engine. So we want to be able to integrate these characters inside a 3D environment so that you can render that in real time to whatever point of view your head has. So this is a test concept render that we've got going. So we've assembled the volumetric video inside Nuke, done a little bit of editing operation, small amounts of cleanup, and we've represented that as, in this case, a point cloud representation. So we've then exported that from Nuke in a point cloud representation. There's many different ways you can represent this data, and we've loaded it into Unity in this case. So you can kind of see the scene layout on the left-hand side. You can see highlighted, it says shot 03, that was shot 03 for the girl here. And if I just play this back for you again, as we move around, you can see that as the camera moves, you can get to see the parallax, you can see the shape of her changing. If we move to an extreme point of view, you can kind of see the quality of depth that you can reconstruct from that sort of camera array. Really, with these experiences, you want to capture and play back the viewpoints recorded from the camera rig itself. So remember, this camera rig was sort of this sort of size. If you take a viewpoint that's extreme and moves around the character, it's going to break down. It's going to go beyond what the original camera's recorded. But you can move your head within that capture space, and you can also reconstruct the geometry so you can see the detail of the surface, and the color visualization there was showing the normals, and so we're doing some fun stuff with relighting as well. So this again is just an early stage tech test. We're going to go into the post-production phase now with this project, pulling in the recorded light field data and prepare that and look at integrating that with Stereo 360 capture, and also exporting that to Unity editor in this case to prepare the experience that played back on the headset. We want to play around with interesting things like lighting and different types of environments as well. So that's just really a sneak peek at some of the things we're exploring, and it's quite good fun here trying to test out in real productions what the problems are with data capture and what tools are needed to solve those production and post-production problems. So thanks very much for listening.